Welcome back. Hopefully exercise 1 was enlightening about other features of a tibble as well as the iris dataset. Now we will look at another useful operation associated with data frames, merging. Consider the following two tables, A and B. Suppose we want to combine A and B into a single table named C. We can merge data using the merge function. The merge function works by taking the right data frame as a parameter, followed by how you want to join, inner, outer, left, or right, followed by a list of field names to join on. There are other parameters that can be passed to the function as well. By default, merge will only include rows from A and B where all keys match between two tables. Let's look at an example. First, let's run the code cell to see the structure of our two tables. Both tables A and B have columns country and year. A also has the column cases, while B has the column population. Now, using merge, let's join the two tables together on country and year. Table C is the merged data. Notice we have all four columns in one table. Inner joins only keep the rows of A and B where the keys match. For example, tables A and B from above were joined using an inner join to create table C. Outer joins keep all rows. Rows are merged using the on keys where there is a match. For non-matches, a missing value of not a number is filled in. Left join of A, B keeps all the rows of A and only merges the rows from B that match. Conversely, right join A, B keeps all rows from B. Only merge rows from A that match will be added. The merge function's parameter how can be used to specify the type of join. Let's look at an example. Given tables D and E, when we use an outer join, all combinations in X and Y are kept. First, let's visualize tables D and E. Next, let's run a couple of operations of various joins. When we use an outer join, all combinations of X and Y are kept. When using the left join, all the unique combinations of X and Y in D are kept. Now let's look at the right join and the inner join. For the right join, all the unique combinations of X and Y in E are remaining. Finally, the inner join only keeps the combinations of X and Y that are present in both tables. Another useful primitive is the apply function. The apply function can apply to a data frame or a column of a data frame known as a series. Let's see a quick example. First, let's recall table C from above. Suppose we wanted to take the year column, which contains 4 digits, and let's transform that data into a 2-digit abbreviated form. First, we're going to make a copy of the original table and call it G. We could use a for loop to cycle through each record of the column and shorten it into the 2 digits. However, it is much more efficient to use the apply function. Using the apply function, we can take the year column of G and apply a function to the whole column at once. The first parameter of the apply function is a function call. We know we only need to retain the last 2 digits of the string. We can use the modulo operator, represented by the % to take the value and divide it by 100. The remainder will be returned. Thus, for example, 1999 modulo 100 returns 99. Using the format function, we only want 2 digits. Thus, we write a function that will be applied to the whole column such that each record is divided by 100 and the 2-digit remainder is left along with a leading apostrophe. Let's run this code and see what this looks like. Now that you have seen the apply function in action, why don't you take a few minutes and try exercise 2 and implement what we've learned.